All right, so in week 5, part 2, we're going to take more of a look at comprehensions, some more list comprehensions, as well as set and dict comprehensions. To create a set comprehension, the notation is essentially the same as for a list. The primary difference is that we're going to use curly braces to surround the comprehension syntax rather than square brackets. All right, so here I'm creating a set S1. Here's my for loop. So the variable C in the for loop is going to be set one by one to the one character substrings in this is a test. And each of those one character substrings, T, then H, then I, then S, and so on, is going to become a member of the set. Now, sets, unlike lists, can only contain one unique copy of each possible value. So when I say S gets a set built from C for C in this is a test, I only get one copy of each of the 7 characters that makes up that string. So we have H space EISAT. And interestingly, of course, a set is unordered. And when I developed this slide, the characters came out in a different order. So you can't know in advance what the order of the items in a set is going to be. In this set, S1, space was one of the one character substrings that we got. Maybe we don't want to have any spaces in our set. So this next comprehension for S2 is the same, except that we have added an if test following the for loop. We're testing whether C is not equal to the space character. So if C is not equal to the space character, then C is going to be put into the set. And our set, S2, is the same as the set S1, except that the space character is not part of the set. Let me make a copy of this guy. I'll copy and paste. And I want to change my variable name to S2. And out here, I'm going to add my if. If the value of the variable C is not equal to a string just consisting of a space. Okay, so there we have HEISAT. Same characters, different order than what's shown on slide 2. A dict comprehension also uses the curly braces, but we have to have key and value to put into the dictionary. In this case, we're using one variable k with values going from 0 up to but not including 6. We're using just the value of k itself as the key and k squared as the value. So this is a little bit artificial to be using k both for the key and to compute the value, but it nevertheless works, so let's just show it. So k is the key, k squared, k squared is the value for k in range 6. There we go. All right, so we have the 0 squared is 0, 1 squared is 1, 2 squared is 4, up to 5 squared is 25. So here's our general form of the comprehension syntax again, this time for the list. For sets, we would use curly braces instead of square brackets. And for dictionaries, the expression would have to involve giving a key and a value. But I want to point out here that this expression is not limited to being just a single value. We already saw an example where the expression was a tuple of 5 values. Some value to the 1/3 power, and then to the 0.5 power, and then the value itself, and squared and cubed. So we can actually use a comprehension as the expression. Didn't highlight very well. Let me try again. We can actually use a comprehension as our expression. Doesn't want to highlight. There. Yay, I got it. We can actually use a comprehension as our expression to create a list of sublists. Okay, so for k in range 4, that is for k going from 0, 1, 2, 3, we're going to create a list of values of j for j in range 2. Now the values for j in range 2 are going to be 0 and 1. All right, so 4 times we're going to create a list, and that list is going to contain values 0 and 1. And so here's the... this just doesn't want to highlight. So so here we've got the list 0, 1 for k equals 0. Here we've got the list 0, 1 for k equals 1. Here we've got the list 0, 1 for k equals 2. And finally the list 0, 1 for k equals 3. Okay, so we have a list of lists in this particular case. In this example, we're using a somewhat more complicated computation involving both the inner for loop variable j and the outer for loop variable k. Okay, now this may seem backwards in some sense, but it's the outer for loop that runs first, because that outer for loop then determines how this expression is going to be evaluated. So initially, k is going to be 0, and with k set to 0, for j in the range from 0 up to but not including 2, that is, j is going to be either 0 or 1, what we're going to compute for this inner list here is 0 plus 0 times 2, so that's going to be a 0. And then j is going to have a value of 1, while k still has a value of 0. So we've got 1 plus 0 times 2. Multiplication has higher precedence, so that's a 1. Now, since we have generated the 2 values for that first sublist, k is then incremented to 1. And with k set to 1, we come back up here to the inner for loop, and we compute 0 plus 1 times 2. 0 plus 2 is a 2. And then 1 plus 1 times 2 is a 3. That's our second sublist. And then k gets increased to 2. Okay, k was equal to 1 for this sublist. Then k was equal... Sorry, I said that incorrectly. K was equal to 0 for this first sublist. Then k was equal to 1 for this next sublist. Now k is going to be equal to 3 for this third... I'll say this right, yeah, I promise. K was equal to 0 for the first sublist. K was equal to 1 for the second sublist. Now k is going to be equal to 2 for the second sublist. So k is equal to 2. And for j, going from 0 or 1, 0 up to but not including 2, we're going to compute 0 plus 2 times 2 is a 4. And then 1 plus 2 times 2 is a 5. So there's our third sublist. And then the fourth sublist is 6 and 7. All right. We have the same general structure for a set, except as I said, we changed the square brackets to curly braces. And previously, I've shown a couple of examples of using if to control whether a value is added to the set or list or not. But in this optional stuff here, instead of using an if, we could use another for loop. And in S3 here, we're showing an example of that. So for C, in this stir ABCD, that is, C is going to take on the values substring little a, then substring little b, then C, then D. So for each possible value of C in that list of 4 possible values, we're going to go through I ranging from 0 up to but not including 3. And the value that we're going to put into our set is whatever the substring C currently is, plus, now plus here means concatenation. All right, C is a stir, and I'm also converting this integer value, 0, 1, or 2, to a stir. Plus is concatenation. So the first time through, the variable C will have a value of little a, and we're going to concatenate little a with 0 converted to a string. That gets me this string, A0. Then we have the next value of a, which is 1, and so that gives me A1. And the next value of I is, I may have misspoken there. The next value of I is 1, so we get A1. The next value of I is, the final value of I is 2, and so we get A2. When we're done looping through this purple for loop, we return, or we come back to this initial for loop, which is going to modify C to be the 1-character substring B. And with C set equal to B, we're then going to set I to 0 and get B0. And then I is 1, B1. And then I is 2, B2. So here's our B0, B1, B2. Okay, so these loops produce this collection of 12 stirs. A0, A1, A2, B0, B1, B2, and then C0, 1, 2, D0, 1, 2. And the fact that they're being displayed in this particular order in my set is just luck, I guess. So let's do this. S3 is going to get C plus the value of I converted to a stir. All right, so we're going to take the value of I, convert that to a stir, and we're going to concatenate the value of C with that stir. This is going to be for C in ABCD. Rats. Sorry, I just hit the enter key by accident. We'll try again. All right, quote. And so for C ranging through A, B, C, D, we're also going to have I ranging from (0, 1, and 2), and there's our entire set. And notice that interactively here, I got the values in a different order than I had gotten the values when I created slide 6. But it is still the same collection of values. Okay, so we have now looked at using comprehensions to create lists, sets, and dictionaries. And it may seem all very abstract, not very practical. But using comprehensions and using the correct combination and sequence of these different collection types can enable you to write very sophisticated and powerful code in a short number of statements. So let's imagine, to illustrate this idea, that we have a document, and it's called doc.txt. And we might want a whole lot of information about what's in this document, doc.txt. We might want to know what are the lines in the document and how many lines are there. What are the words in the document and how many words are there. How often does each word occur? That is, what is the frequency of occurrence of each word? Which words occur the most often? Which words occur the least often? It sounds like it ought to be, a lot of looping and tedium and grinding our way through this text file to get to all these answers. But in fact, the entire program only needs a couple of slides involving a bunch of comprehensions. So let me open this program file, which is called docstats. And all right, that fills up more than will fit into our viewing area. So let me get on here what will actually fit. Okay, so let's talk our way through this thing, and I'm going to talk through it on slides 8 and 9. Well, one thing to remember is that when you open a file for input, you get an iterable object that you can read lines from in a loop. So here I'm using with open of our document file for reading text, and we're going to name that open thing fin, F-I-N, file input. Now, since fin is iterable, I can read the entire list of lines by just using a comprehension on fin. Okay? In fact, I can interactively type in this code so that we can go through it step by step. So I'm going to say with open doc.txt for reading text with the encoding of UTF-8, which includes ASCII. This is an ASCII file. So with open of that file as FIN, let's create a line list of all the lines in the file. Each line is going to be everything up to but not including the new line character. Okay, so for each line from the input file, what I want to put into my list is every character on the line except for the new line character that comes at the end of the line. So bing, bing, done. I have read my file and I've created my list of lines. If I say line, list, oh, I should show you the silly file that we have in here. Here's the silly file that's contained within doc.txt. This is a poem from Alice in Wonderland, which I like to use because it's short and it's amusing and it's fairly easy to work with. Okay, back to the code. So I can display parts of line lists using slices. So let me display just the first 4 lines, lines 0, 1, 2, and 3. All right. How doth the little, and then we have a blank line, and then we have by Lewis Carroll, and then another blank line. So line list is my list of lines. I can get all of the words from that line list I can create a word list by saying, give me each word for line in line list and for word in line dot split each line at spaces. Okay, so for line in line list, what I want to do is split the line at spaces. That will give me my list, that will give me my individual words, and I only want to include words in my word list if the words have some characters in them. So if the length of the word is greater than 0, that's a word that I want to include in my word list. Why do I care about that? Well, it turns out that there are a bunch of blank spaces in this file. And the split function here, if I tell split to split this line into a list separated by spaces, I'm going to end up with a whole bunch of empty words as a consequence of these sequences of spaces. Because I've got a space, and then I've got an empty word followed by another space. And then I've got an empty word followed by another space, and so on. I don't want to store those empty words. So let me now get my list of words, and let's just see the first 10 words. Let's slice up to, but not including 10. There we are. So, how doth the little crocodile by Lewis Carroll, how doth. Those are the first 10 words from the file. I have some duplicates in here, you'll notice. I've got how a couple of times. I've also got doth a couple of times, although they're not spelled quite the same. I've got a capital D here and a lowercase d there. I might wish to treat those as the same word. But for now, let me just create a set of the unique words in this poem by giving this word list to a set conversion. And I'll display the word set. This might be pretty long. Okay, it's a short poem, so it's not terribly long. So we've got tale in golden the, how little doth. And later on I have doth with a capital D. So I am treating doth with a lowercase and doth with an uppercase different. Similarly, I'm treating the with a lowercase t and the with an uppercase t differently. We can argue that that's a bug, but you know, for illustration purposes, that's okay. Now, so I have the lines, I have the words, I have the collection of unique words. How do I get the frequency of occurrence of each word? Well, I have a set of words, and so for each word in that set, I'm guaranteed that each of these words is going to be unique from all the other words. Let me store into a dictionary that word and the count of the number of times that that word appears in the word list. All right, so word to freak is my dictionary. The key is going to be the word. The value associated with that word is going to be that word's frequency in the word list, which I can get by using the count method. All right, so I will count the number of times that word occurs in the word list, and I'm going to do that for each word in the word set. And poof, now I have word to freak. All right, so tail appears once, in appears once, How occurs 4 times. Little occurs twice, and so on. So most of these words only occur 1 time, but several of them occur 2 or 3 or 4 times. Now what I'd like to do is to find out which words are most common and which words are least common. My word to freak dictionary has the word as the key. That is, the word as the first part of the the word as the first thing in the item, and its frequency as the second thing in the item. I would like to be able to sort these things by the frequency. I know that a list is sortable, so what I'd like to do is to get these contents of this dictionary into a list, but with the keys and values reversed, so that the counts come first and the words come afterward in tuples. So I want a list of tuples where each tuple contains a count of the time that of the number of times the word occurs, followed by the word. Then I can sort that list to get the lower counts at the beginning of the list and the higher counts later in the list. So that's what's going on with, that's what's going on with this next part. Instead of word to freak, I want freak to word. Let's see. So for IT item in word to freak dot items. All right, dot items is one of my iterables for stepping through a dictionary. So for IT in word to freak dot items, let me print each item. And there we go. So there are my items. Each item consists of a word and then the number of times that that word occurs. Tail and golden. The is 3 times. How is 4 times. And is twice. But instead of printing that stuff onto my screen, what I really want to do is to collect that into a list with the count first and the word second. So let's repeat what I did up here. I want to copy and paste this, but I'm going to make a change to it. So instead of printing out the item, let's instead print out item sub 1 followed by item sub 2. No. Sorry. Item sub 1, which is the frequency, followed by item sub 0, which is the word that has that frequency. Now, as you can see, I have my counts ahead of my words. And so if I put those things in parentheses to make it a tuple, and then I create a list of those tuples, I'll be in good shape. So freak to word is a list of tuples where each tuple has the count first and the word second, for each item in word to freak. So now I have freak to word as a list. Well, I would if I spelled it correctly. Freak to word as a list. Okay. 1 count for tail, 1 count for in, 1 count for golden. This thing can be directly sorted. Freak to word.sort. And now when I look at freak to word, I have the lowest count items first and the highest count items last. Now, there's a ton of words that only occur one time in the poem. The sort facility of the list sorts tuples on an item-by-item basis. So all of the ones come out ahead of the twos, which come out ahead of the threes, and then the fours, and so on. Within the ones, these are subsorted by the second component, which is a string. So capital C little a comes ahead of capital C little r, which comes ahead of capital D, which comes ahead of capital I, which comes ahead of capital L little e, and then capital L little I, and then N. So you can see that within a given frequency, the tuples are subsorted by the word. And in the ASCII character set, all of the capital letters, C in Carol, C in crocodile, D in doth, all of those come ahead of all of the lowercase letters. Little b in buy, little c in cheerfully, little c in clause, etc. So let's take a look at this. So I opened the file and read that file into a list of lines. From that list of lines, I generated a list of words. From that list of words, I generated a set of the unique words. Then I generated a dictionary mapping from the word to how many times the word occurs. Finally, I created a list that had that same information in reverse order. So this was a list where I had tuples containing the count and then the word, which I sorted. So now I have all of the information that I want in these various collections, most of which I created using comprehensions. So I had a list comprehension to get my line list. I had another list comprehension to get my word list. I just used the conversion function to convert that word list into a set. And then I used a comprehension to construct my word to freak dictionary and another comprehension to get my freak to word list. And now I can just answer all these questions that I had. How many lines are there in the file? Well, that's just the length of line list. How many words are there in the file? Well, that's the length of word set or word list. How many unique words are there in the document? Well, that's the number of words in the word set. Okay, word list has all the words in the order that they occur in the file. Word set has just one copy of each of the various words. All right, so there are 48 total words, but only 40 unique words. And the least common word is freak to word sub-0. And the word is the, okay, freak to word sub-0 is a tuple. It's this tuple containing the number of times that Carol occurs. Freak to word sub-0 sub-1 is the word Carol. And that word occurs freak to word sub-0 sub-0 one time. So that word Carol occurs one time. So forgetting about the fact that there are all kinds of words that only occur one time, we can say, well, Carol is certainly one of the least common words in the document. It does occur, but it only occurs one time. Now, the most common word in the document is going to be freak to word. What's the last item in this list? Well, the last item in the list is always -1. And then the word for that item is how freq to word sub -1 sub 0 is the number of times that that word occurs. Okay, so comprehensions are not trivial things to get used to. You do have to do a lot of practice, and the fact that you can have sort of nested lists within lists, tuples within lists, tuples within sets. You can conditionally decide to add things or not add things using an if test. You can have loops on loops. All of this takes a lot of practice and experimentation to become comfortable with. However, once you do become comfortable with it, it is extraordinarily powerful for doing very sophisticated data processing on any kind of data that you have. You can slosh things back and forth between lists and dictionaries and sets and tuples and so on to rapidly pull in and organize your data in the way that makes it convenient to operate on. So, it's very Pythonic. It's totally cool. Now, I do have one tiny bit of advice about efficiency matters. If you're writing small programs, efficiency is often a matter of getting the program working in as little time as you can. But you may discover that even though your program is small, it takes a long time for the program to run. Unacceptably long, let's say. Now, what does unacceptably long mean? Unacceptably long means unacceptably long to you, or unacceptably long to the user, or to your boss, or to your customer. If you discover that the program that you have is running unacceptably long, you need to analyze the program to see whether there's some part of it that can be sped up. And in this statement here, where we're creating our word to frequency dictionary, what we've said is, for each word in the set of unique words, let us count in our word list the number of times that that word occurs. That seems perfectly reasonable. For each word, for each unique word in our document, let's look through the word list to see how many times that word occurs. Seems entirely reasonable. But in fact, this creates what's called an order n squared algorithm. And the bigger your word set gets, the bigger your word list gets, the faster this is going to get slower and slower and slower and slower. Because let's suppose that there are n words in the word set. And let's suppose that the list of all the words is almost the same size as the word set is. And in fact, we discovered that that was true in our example. Our word list had 48 total words in it. 40 of those words were unique words. So more or less, in our case, the number of unique words was almost the same as the number of total words. And so for each of these 40 words, we're going through this list of 48 words to see how many times a given word occurs. So it's easy to multiply 40 by 48. Just call it 40 squared. It's worse than 40 squared. Okay? So if your word count gets to be 100, now you've got 100 squared, which is much worse than 40 squared. And if your words get to be, 10,000, now you've got 10,000 squared, which is way, 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 way worse than 1,000 squared or 100 squared. So this is something that we could speed up. Now, how do we speed it up? Well, let's break things up like so. Let's get a word-to-freak dictionary initialized with a count of 0 for every word in our set of words. It only takes looking at n words to set up that word to frequency. Okay, not n squared words. It only takes n words to set up this word to frequency dictionary. Then, for each word in our word list, I don't like this highlighting thing here. All right, so for each word in our word list, let's look at that word one time, and within the dictionary, we'll just add 1 to the count of that particular word. So we're looking at the word set one time, which is n words. We're looking at each word in the word list one time, which is approximately also n words. So we've got n plus n instead of n times n. This is what's called an order n, or a linear algorithm. And as you get bigger and bigger and bigger values for n, as you get more and more and more words in your document, the performance of this is going to slow down. It's going to slow down at a much slower pace than the order n squared algorithm. Okay, so I have hidden a couple of long lectures in these 2 slides. I don't really have time to get into all the theory of how to go about computing algorithm performance and what this big O notation really means mathematically and so on. I do just want to point out that you will encounter situations where when you get your program to work, it runs too slowly. And then you need to figure out which part of it is running too slowly and see if you can just rewrite that part of the code to significantly speed up that part of the code. All right, well, that's the end of my efficiency tidbit. So in this lab, you'll have a chance to do some more comprehensions, including nested comprehensions like lists of lists, and also multi-loop comprehensions. Okie doke.